Hi everyone! So I was able to get my hands on a mini iPad, so no more writing with the mouse. It's going to be a little bit neater, maybe not a lot neater, but a little bit neater than before. This is lesson 3.6, which is on scale diagrams. So for this video, I'm hoping that you'll be able to create scale diagrams and determine scales. Now, we're going to learn how to measure diagrams, and I have a little bit of an example on the right-hand side. You'll notice a black house, and so if I was going to measure this diagram, I might take a ruler and figure out how tall it is, so the height, and then I also might figure out how wide it is. So those are some dimensions that I can use that are my original measurements. Now, using some sort of a scale factor, I can create new measurements. So I could make the diagram larger, okay, which is called an enlargement. You'll notice that the blue house is a lot bigger than the original. Or I can make it smaller, which is called a reduction. So notice that the red house is a lot smaller than the black house. Now, the measurements for the height and the width of the blue and the red house must have been enlarged or reduced by that scale factor. Okay, so that it's proportional. Now, what I'd like you to be able to do by the end of this video is to be able to use these new measurements to actually draw a larger or smaller version of your original picture. So let's see how that's done. A scale is something that we're going to use in order to compare a bigger or larger picture to the original object. So for example, if you are walking in a shopping mall is a large object, but if you're going to draw a picture of it, like, you know, the shopping malls usually have those maps so that you know where to find the stores, that's a smaller version of the huge shopping mall. All right, and it has to be proportional so that when you look at the diagram, you can see where the food court is, and then you know where to walk in the large shopping mall. All right, another example would be down below where you see the large tree on the left-hand side. Okay, I'm just going to put L for large. And then you see the small tree on the right-hand side, and I'm going to put S for small. So the large tree seems to be, someone measured, I don't know how they measured, but maybe they climbed all the way up to the top, and it was 200 centimeters tall. Now, we can also find the measurement of the small tree, and I actually measured the small tree as a diagram. When I printed off this lesson, I used a ruler and I measured, and it was about 3.3 centimeters. Now you'll notice that obviously the large tree should be a bigger number than the small tree, which is a smaller number. If you wanted to write it as a scale, you would just write 200 to, so that's what these two dots are, a comparison, so you can even say it as the word 2. So 200 to 3.3. All right, and if you want to, you can always write it as a fraction as well. So I usually like to put the 200 on the top and then the 3.3 on the bottom. All right, so let's try some examples where I give you an original measurement and you can use the orange scale to figure out the new measurement. So let's start off with this example. Given the following scales and diagrams, determine the actual size of the objects. Okay, so here's the diagram, and it seems to be kind of small. All right, and then what we want to do is we want to find the measurement for the large. Now the small is going to be in red, so I should probably have written this in red, and then the large is going to be in blue. All right, now using the scale, which I already put in a box at the top in orange, we're going to determine which one the small and the large are. So the larger number goes with the large diagram, and the smaller number goes with the small diagram. That looks like a 5, but it's an S. Okay. Now, in order to do my calculations, the first thing I'm going to do is notice that on the right-hand side, I already wrote down the scale in orange, and it has the small number, which I put on the top. It also has the large number. Okay, and we write it as a fraction because right beside it we're going to write down an equivalent fraction, and we're actually going to use the numbers that they gave us in the diagram. So I've measured with a ruler the smaller diagram, and it turned out to be 2.5 centimeters. I want to know how tall the actual apple is going to be. So notice that there's a question mark, and I'm just going to replace it with an X instead so that we can use our solving equation skills in order to figure out what that letter is. Okay, so the 2.5 and the X are going to go into the second fraction. Can you guess where they're going to go? So the 2.5 is with the small diagram, and so I'm going to put it on the top. It's going to go with that 1 because on the top was the small number. So this one was from the small diagram, and so was this one. All right, so we want to put both of the smalls on the top, and notice that I have them both in red anyway, so it's easier for you to see that the reds should go on the top together. Now the 3 goes with the large diagram, and this one was also with the large diagram, so they're going to both go on the bottom. And I put them both in blue so that you can follow. All right, so what you want to do is just make sure that you have both of the same colors on the top and both of the same colors on the bottom, or both smalls on the top and both larges on the bottom if you're just using one color. Make sure that you don't switch up one of the fractions on accident, because then you're going to get a different answer. Okay, now that you have your equivalent fractions, you're going to solve. Now the way that we solve these two fractions with an equal sign in the middle is we use something called cross multiplying. And so what we do is we take the things that are diagonally across from each other and we multiply them. 1 times x is going to give you 1x. Then you put an equal sign and you do the other diagonal. So you multiply the 3 and the 2.5. So the next step would be figuring out what that answer is. 3 times 2.5 is going to be 7.5. And that's my final answer because you have the x and you will have the answer for what x represents. So therefore, the apple, oh my goodness. See, I told you that I wasn't going to be much neater with this thing. The apple is 7.5 centimeters tall. So you just found out this height. And yes, we always want to put a therefore statement at the end just so that we answer the question. Okay, so let's try that again. Here are 2 leaves. You have the larger leaf and you have the smaller leaf. All right, so we take a look at the scale that they gave us. We want to make sure that we recognize that the smaller number is the small and that the larger number is the large. Okay, we also did one measurement with our ruler, measured how long that was, which is 7.5 centimeters, and we want to know how long the other leaf is. Okay, so why don't I just replace this with the letter X so that we can solve for it. So notice that I already put my orange scale with the large 4 and then the small 1 on the bottom. Okay, and we have to fill out that equivalent fraction. So the 7.5 and that x have to go into the second fraction. The blue is going to go with the blue on the top, so 7.5 was also blue, it was also large. And the x, which is small, is going to go on the bottom with the other red. Okay, now we're going to cross multiply. So 4 times x diagonally is 4x. Remember to put an equal sign, and then 1 times 7.5. And our next step is we're actually going to multiply those. So 1 times 7.5 is just 7.5. Now the last step is get rid of that 4 by doing a division. But if you do it on one side, you got to do it on both sides. So you get 1x by itself, and I believe that's about 1.875. So therefore, the leaf is 1.875 centimeters long. Okay, so our last question, I'd like you to try by yourself. The answer should be 21.25, and they gave you a scale right here in inches, 2 inches to 5 feet. So you're actually looking for the height of the larger building. Okay, so other things that you could compare this to, or you can kind of, other examples, I should say, are you could always do this with currency exchange. So exchanging to different kinds of currency internationally. Or if you wanted to make a recipe, and let's say you were making a recipe for cookies, and you decided, oh, you know what, a lot more people want cookies, so I have to enlarge or scale up my recipe. So there's a lot of different ways that you can use scale diagrams.